Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Inayatullah, your mathematics teacher, and today we will have lecture number 2 of your numerical analysis. So let us start lecture number 2. That is about interpolation, which is chapter number 3 of your textbook. Interpolation. And what is interpolation? Let us start from a small table here, which is included in your book. There are some certain values of x. You see here, this is x, and these values are assigned to x. We see that the gap between these values is the same. The gap between 0 and 1 is 1, 1 and 2 is 1, and 2 and 3 is 1, and so on and so on, up to 100. So we have equally placed the values of x with the equal interval, with equal subinterval. The values of these values of x, these values of x are called arguments. These are called arguments, and this is f of x, a function which will be given to you, or whose values will be given to you. For example, these are the functional values: 10, 85, 90, 98, and so on. It is not necessary that these values are assigned to f of x, but this is just an example. So these are the values of f of x. So we see that here the values of x are equally spaced. The values of x are equally spaced. You see here, equally spaced. The space between 0 and 1 is 1, 1 and 2 is 2, 2 and 3 is 1, and so on and so on. For which function of x, f of x, is calculated. So remember that we are dealing with equally spaced arguments, because the values of x are called arguments. So we are dealing with equally spaced argument for the time being. The process, now I'm going to define this word interpolation. What is interpolation? So remember that you see that for x there is the value of f of x, which is 10. For 1 there is the value of f of x, which is 85. For 2, for x equal to 2, here is the value of f of x, which is 90. And for 3, here is the value of f of x, 98, and so and so. For example, if somebody asks us to find the value of f of x for the value of x which is not included in this table, for example here 2.5, and somebody asks us to find the value of f of x for x equal to 2.5. So similarly, that may be over here, that may be over here, that may be somewhere here, but not exactly these values. So we see that this value, for example 2.5, is between all these values from 0 to 100. So if we want to calculate f of x for the value of x which is somewhere here, not outside these values, not 101, not here -1, but between somewhere here, some value of x which is between 2 and 3, or 1 and 2, and so on. So this is what is interpolation. The process of calculating the value of f of x for a certain value of x, for a certain value of x. Remember that this lecture is very much important because this is the initiative of this chapter, and I'm going to define here some basic ideas which will be used later on in all this chapter. So to the process of calculating the value of f of x for a certain value of x between 0 and 100, between 0 and 100, somewhere here, but not given in the table. That value of x not given in the table, for example 2.5. So this process is called interpolation. This was called interpolation. And if there is some value which lies outside this table, for example 101 or 102, or here -1 -2, so this process is called extrapolation, but we are going to deal with interpolation, not with extrapolation. So the main concern of our lecture is interpolation. So I think that is that will be clear to you people. Thirdly, I have recently told you people that the values of x are denoted by x0, x1, x2 and xn. For example, this value of x is, will be denoted by x0. This is x0. That is x1. That is x2. That is x3, and so on. So this is say xn. So these values of x are called arguments, as I told you people, and the corresponding values of f of x, the corresponding value of f of x are 10, 85, 90, 98 and so on. So these values of f of x will be denoted by f of x naught, because this is, if this is x naught, so according to, if this is x naught, so this will be f of x naught, this 10. If this is x1, so this value will be f of x1. If this is x2, so this value will be f of x2, and so on. So I write here that the corresponding values of f of x are f of x naught, f of x1 and f of xn up to here. Now there are notations that we denote f of x naught, we denote this f of x naught by f naught, by ignoring this x. So f of x naught is f naught, f of x1 is f1, f of x2 is f2, f of xn is fn. So we put the base of x in the base of f. So that is the notation for all those functional values. So I hope these basics will be clear to you people. If these are clear, then let's go forward. We have got some notes which are very much important, and you need to remember, memorize, and these notes will be in your mind when solving questions regarding interpolation. As I told you that the values of x are arguments which are denoted by x0, x1 and so on, and f of x is a function whose values will be denoted by f of naught. That is actually f of x naught, but we have got a notation for f of x naught which is f naught. And similarly, if this is x1, this will be f1 and so on, so on, so on. That is a table. So the above tabular values can be written in ordered pair form as under. How could we write these tabular values? I mean, you see, this is x naught, so the corresponding value of x naught is f naught. So one ordered pair is formed, which is x naught f naught. So that is x naught f naught. Similarly, x1 f1, x2 f2, x3 f3, xn minus 1 fn minus 1, xn fn. So this table can be written in the form of ordered pair, just like this one. If ordered pairs are given to you people, and you want to make a table from these ordered pairs, so you will write these ordered pairs in this form, that is x naught f naught, x1 f1, and so on and so on. Thirdly, the difference of two consecutive values of x is called step size, which is denoted by a small h. The difference of two consecutive values of x. What are two consecutive values of x? X naught, x1. These are two consecutive values of x. X1, x2. These are two consecutive values of x. X2, x3. These are consecutive. So the difference between two consecutive values, I mean x1 minus x naught, or x2 minus x1, or x3 minus x2, are generally xn minus xn minus 1. So this is called the step size, and this step size is denoted by small h, and this small h is given in this form, that is x1 minus x naught, or x2 minus x1, and so on and so on. So you'll find step size by the difference of two consecutive values of x, which is denoted by h. Thirdly, the values of x, the value of x for which f of x is to be determined. So there will be a value of x, maybe between x2 and x3, maybe between x0 and x1, somewhere here, or somewhere here, maybe somewhere here, maybe somewhere here, between two values of x, I mean, which is not given in the table. So whenever you need to determine this function f of x for the value of x which is not given in the table, but somewhere between two values of x, so that value of x will be denoted by xp. What does it mean? If x lies here, so that will be your xp. If that x lies here, that will be your xp, that will be your xp, that will be your xp. So xp is denoted by xp, and xp is equal to x0 plus ph. You know what is x0? That is the initial value of x. You know what is h? That is the step size, maybe calculated from one of these formulas. And what is p? So p is actually this thing. You can find p from this equation, that if you convert x0 towards that side, so that will be xp minus x0, and then divide it by h. So p will be equal to xp minus x0 divided by h. So this is p. Remember this value of p, that is xp, which is the value of x for which we are going to determine f of x. So xp minus x0, initial value of x, divided by the step size, that is p. And here p is given by the value of p always lie between 0 and 1. I mean that will not exceed 0 and not exceed 1. This value will lie between 0 and 1, maybe 0.1, 0.2, and so on. So this means that x0 is selected before xp. What does it mean? I will tell you later on in this lecture that what does this sentence mean. So let us start from the next slide. So there are some formulas or formulae for equally spaced arguments. Interpolation formulae for equally spaced arguments. The first one is Newton's forward difference interpolation formula. the same Newton formula but with the backward difference. And third one, Stirling's formula, then Bessel's formula, then Everett's formula, then Gauss forward formula, and then Gauss backward formula. And this last one is Lagrange's formula, but this Lagrange's formula will be used for unequally spaced arguments. These all formulas will be used for interpolation for equally spaced arguments, and the last one will be for unequally spaced argument. So you need to remember these formulas. That is your whole chapter. You see all these formulas, 1 2 3 4 5 6 7 8. There are 8 formulas in your chapter, so you need to remember these formulas. The application of these formulas is very simple. You just need to, how could you memorize a formula? You need to write a formula so many times, as many times as you can. If you need to learn Newton's forward formula, so you need to write Newton's forward formula 4 or 5 times in a copy, so you will be able to memorize or remember this formula. So let us start from Newton's forward difference interpolation formula, and you need to listen right from here very carefully, because the steps which I am going to explain here will be followed for all the rest of the formulas which are coming forward. So Newton's forward difference interpolation formula, I am going to write a procedure for this formula. The first one is, you will be given a set of data in the form of ordered pair, just like x0, f0, x1, f1, and so on. But this data may also be written in the table form. How could you write the table from ordered pairs? I told you before that x0, then f0, x1, then f1, and so on. So a set of data will be given to you people, and you'll be asked to find the value of f. You'll be asked to find the value of f for a value of x which is not given in the table but between two values of x. So what do? Construct a difference table. The first step is, you need to construct a difference table and identify f0, delta f0, delta square f0, delta cube f0, and so on. We have already studied that how could we construct a difference table and how could we identify the differences of a functional value. How could we identify delta f0, delta square f0, delta cube f0? If you take your copy and study the first lecture, so there we will study that how could we identify delta f0, delta square f0, delta cube f0, and so on. So first of all, you need to construct a difference table and identify these values. Thirdly, calculate h. As I told you people that h is the step size which can be calculated by x1 minus x0 or x2 minus x1, and so on. And secondly, you need to calculate p. I told you before that p will be calculated by xp minus x0 divided by h. So you need to calculate these two things. xp will be given to you people for which the functional value is required. So remember that xp will be given to you people. So next, when all is done, when you construct a difference table and identify these differences and calculate the values of hp, then xp will be given to you people. So thirdly, you need to use Newton's forward difference formula to calculate f of xp, and f of xp is denoted by f of p, as of just like this notation. This f naught is actually f of x naught. So f of xp will be denoted by fp, the base of fsp. So what is Newton's forward difference formula? This formula is this one. F of p, fp, or you can say that f of xp, this is equal to f naught plus p, which we have calculated right here, delta f naught, which we have observed from there, then p into p minus 1 by 2 factorial, second difference of f naught, then p into p minus 1, p minus 2 by 3 factorial. See, if there is second difference, then this is 2 factorial. That is the third difference, so this is 3 factorial. And thirdly, if this is the fourth difference, so this is 4 factorial, and so on. This is just like binomial expansion, if you remember your first year course. So this is the formula for Newton's forward difference interpolation. So let us start. Let us solve an example, a question, in order to explain this formula. Here's an example. The first part is compute difference table for the following set of data points. You are given data points 0.00, 0.0000. So this is actually x naught and this is f naught. This is x1, this is f1. This is x2, this is f2. This is x3, this is f3. This is x4 and this is f4. So you need to construct a difference table, which is quite simple for you people, that how could we construct a difference table. That is the first part of this example. And secondly, you need to use Newton's forward difference interpolation formula to interpolate f of 0.125. You see that 0.125 is nowhere here. You see, nowhere here. 0.125 lies between 0.00 and 0.25. Anyways, you need to interpolate f of 0.125 by using Newton's forward difference formula. Let us start the answer. Difference table is as follows. That is a difference table. You see, all values of x are written in the form of a column. These are the values of x: 0.00, 0.25, 0.50, 0.75 and 1.00. These are written here. And the values of f of x, actually the second value of each ordered pair, are the values of f of x. So we write all those values in the second column. Thirdly, we have written, because delta is used in Newton forward difference interpolation formula, so we write here delta. That is actually the first difference, that is the second difference, third difference and fourth difference. So what is the first difference? This value, f of 1 minus f of naught, will be written between these two values of f here. Then this is f2 minus f1 will be written here between these two values. Then f3 minus f2 will be written here, and f4 minus f3 will be written between these two values of f here. So second difference is just like that, this minus that between these two here, then this minus that will be here, this minus that will be here. Third difference is second minus first, there. Third minus second, there. Then the fourth difference is first minus second minus first, so that is 0.0157. So that is the difference table. Then thirdly, what is the differences? I mean delta f naught. How could you determine what is the value of f naught? Remember that. Just look at this value 0.125. We need to calculate f for this value of x. So this value of x is xp. This value lie between 0.00 and 0.25. You see that 0.125 lies between 0.00 and 0.25. So above this 0.125, this value will be considered as x naught, and the coming value, the next value, will be considered as x1. This is very important note, that you need to note the value of xp. This is the value of xp, and you will search that this value of xp lies between which two values of x. 0.125, this is actually 0.1, so 0.1 lies between 0.0 and 0.2. It's very simple. Not between 0.25 and 0.50. Between 0.2 and 0.5 there is 0.3, 0.4, not 0.1. So 0.125 lies between 0.00 and 0.25. So the above value is your x naught and below value is x1, and this value is actually xp, which is given to you people, for which you are going to calculate the functional value. So if this is x naught, then in front of this naught, this value of f is f naught, and this value is f1, this is f2, this is f3, this is f4. So if this is f naught, so delta tells us, so that if this is f naught, then the second value is delta f naught. This value is delta square f naught. This is delta cube f naught. This is delta 4 f naught. So whenever you need to check the values of delta f naught, so that will be from upstairs to downstairs. F naught, delta f naught, delta square f naught, delta cube f naught, from upstairs to downstairs. So you see, you memorize, you mention these values. So you just need to put all these values in the formula, and then use your calculator to calculate the answer, and put the value of xp, and so on and so on. So that is the table. Xp is 0.125, xp is 0.125, x naught is 0.00, and x1 is 0.25. So I told you in the procedure that then we will need to calculate the value of h from x1 minus x naught. So this is x1 0.25 minus x naught 0.00, so that is 0.25. So h is 0.25. Next we need to calculate p. P is xp minus x naught by h. So xp is 0.125 minus x naught is 0.00 divided by h, which you have calculated here, 0.25. So calculate this fraction, you will get 0.5. So p is 0.5, and we see that 0.5 lies between 0 and 1, as we studied that p lies between 0 and 1. Anyways, this is the value of p, which is 0.5. So the next step is you need to apply Newton's forward difference interpolation formula, which is this formula. We see from the table that we have found 4 difference of f naught, so we will extend the formula of Newton's up to 4 difference, delta 4 f naught. So simply you need to replace the values. What is the value of xp? The value of xp is here 0.125. This is xp. The value of f naught from the table 0.00. The value of p is 0.5. This is the value of p. The value of delta f naught is from table is this, that is p, so p is here. Then p minus 1, so this is p minus 1. 2 factorial is 2 into 1, and delta square f naught from the table is minus 0.0321. And secondly, from here p into p minus 1, p minus 2, so p into p minus 1, p minus 2 by 3 factorial. 3 factorial is 3 into 2 into 1, and delta cube f naught is from table there. Then these values right here, and delta 4 f naught from table is there. So whenever you calculate this sum with the help of your calculator, you'll get f of 0.125 is equal to 0.1351. So this is the answer of this question. You see that for the value of x, which is 0.125, this value of x is not included in the table. So for this value of x, we have calculated the value of f as 0.1351. So this is the whole procedure for Newton's forward difference formula. So I hope that you will be able to understand the idea